Alright, so we're going to do pages 106 of your student journal. We're going to do number 6 through 11. These ideas are coming from the Big Ideal Math people, and I'm just showing you how to work out the problems. Alright, so here we go with more composition or sequence of transformations. So here we have a rotation and a reflection. Before I do anything, I'm going to go ahead and write the rule. And I'm going to write it as I need it. And this time I'm going to go clockwise. They're still not giving us a direction, but I'm going to go clockwise. So the rule tells me this is 0 and 360. And this is 90. This is 180. And this is 270. And it's telling me to go 270 about the origin. So this tells me to keep the y negative. Flip x and y and make the y negative. So if we go here, I'm going to write the ordered pairs for m down. And the ordered pair for m is going to be 3 and 4. And the ordered pair for n is going to be 3 and 1. So the rule tells me to switch them to get the m prime. I need to switch x and y. This is x, this is y. I need to switch them and make the y negative. So negative 4, comma 3, m prime would be negative 1, comma 3. Alright, and I'm going to go ahead and plot this. So that tells me negative 4, 1, 2, 3. Well, negative 4, 1, 2, 3. M prime, negative 1, which is right here, and 3. That's your n prime. Okay, so now the next rule says to reflect in the line y equals x. Well, there we go. We have a rule for that one. And all we have to do is just switch x and y. So get the m double prime. And you get 3, negative 4, and then n, 3, negative 1. That's the rule for y equals x. It's just to switch x and y. Okay, so here we're going to go 3, negative 4, and that's going to be m double prime, and then we're going to go 3 and negative 1 right here. And that's n double prime, and you finish. You did it. Alright, so now we're going to go here where we're going to rotate 90 degrees about the origin. Again, guys, let me tell you, on any standardized test, they're going to tell you what direction to go in. So make sure you go in the right direction. Since they didn't tell me a direction here, I'm going to go clockwise. This one I went counterclockwise, and this one I'm going to go clockwise with, since it didn't tell me a direction. But direction is important, guys. So here, you want to say counter clockwise is what I did here. Oh no, I didn't go counterclockwise in this problem. I went clockwise. 207 degrees clockwise. And in this problem, I'm going to go 90 degrees clockwise. And the rule for 90 degrees clockwise is to just switch x and y and make x negative. So it says rotate about the origin. I'm going to write my primes down first. My originals down first. And that looks like to be negative 1, 0. And here it looks like to be 3 and negative 3. And to do the rule, then n double prime would be switch x and y and take the opposite of x. So I'm switching them, and then I took the opposite of 1. Switching them and taking the opposite of positive 3, which is negative 3. Okay, and then I'm going to graph this. N double prime. M double prime. And there you go. Now it's telling me to move, do the translation next. It's just telling me to move to the left 5, and the y does nothing. Alright, so we're just going to move to the left 5, then 1, 2, 3, 4. Well, I'm already here. That's there. That's my N. Oh, I'm calling these double primes. I'm gonna call it triple prime. I know I missed it, but I'm gonna call it triple prime so I'll know what's going on. M, I'm right here, so 1, 2, 3, 4, and then 5, and that's M triple prime. And we're finished. Alright. And now it says exercise 8 and 9. Graph triangle JKL with vertices J is 2, 3, K is 1, -1, L is -1, 0, and its images after the composition. Alright, so it wants me to rotate 180 degrees about the origin and then reflect X equals -2. Now, does the direction matter when we're rotating 180 degrees? It doesn't matter. Rather, it goes clockwise or counterclockwise. But the rule is going to be the same. Take the opposite of X and the opposite of Y. Alright, so let me go ahead and plot the pre-image. So 1, 2, 1, 2, 3. 1, -1. So this is J. This is K. And this is L. Alright. And then next, it wants me to go 180 degrees about the origin. So that means J prime would be, let me change this color. This probably look bad on you guys' screen. Alright, so J prime would be just to take the opposite of both X and Y. K prime would be to take the opposite of X and Y. And L prime would also be take the opposite of X and Y. 0 is neutral, so you don't need to worry about changing that one. So -2, -3, 1, 2, 3. J prime, and then -1, +1. This is me plotting the rotation in 1. There you go. So that's the rotation 180 degrees about the origin. And then now it's saying to reflect over the line X equals 2. So I'm going to find 2 on the x-axis. 1, 2. That's right here. And here is my line of reflection. Right there. Okay. And now I'm going to count from the blue one to get me where I need to go. And I'm going to make it light blue. So I'm 1 here. So I'm going to go 1 here. L double prime. 1, 2, 1, 2, 3. So I'm going to do 1, 2, 3 somewhere out here. It's K double prime, and then on 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4 out here somewhere, and that is J double prime, and you're finished. Now mine might be a little off because I don't have the rest of the graph over here, but you should be able to fold across the line of reflection, and the two should touch, and you're finished. Alright, let's go and do the next one, where I'm going to plot the pre-image first. So 1, 2, 1, 2, 3. 1, -1. So this is J, this is K, and then this is -1, 0, L. Alright, and then I'm going to go down 4, down 4. We'll go to the left 4 and down 4. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. So that's put my L prime right here. Woo! I might have should have did these scales a little differently, but it'll be alright. I'll figure it out. So 1, 2, 3. That was one more out. 4. And then here is 1, 2, 3, 4. And I need, well, let me go back 4 first. 1, 2, 3, 4. 1, 2, 3, 4. That is going to be K prime. You can always change the scale to make sure you fit on the grid. I'm just refusing to change the scale. You can change your scales though. 1, 2, 3, 4. 1, 2, 3, and 4. And this is J prime. Alright, so I did that translation. Now it tells me to rotate 280 degrees about the origin. Once again, it did not give direction, so I'm going to do counterclockwise. So that means I'm going to turn to the left. So if I go up here and look at my rule, going to the left 270 degrees, then that puts me here at switch the x and y and make the x negative. Alright, so first I gotta write these points down. So J prime would be 1, 1, 2. So -2 and -1 is J prime. K prime would be 1, 2, 3. 1, 2, 3, 4, 5. -3, -5. JK L. One, two, three. 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So -5 and -4. Alright, so I got that taken care of. And now all I have to do is what the rule says up here. If I'm going 270 degrees counterclockwise, it tells me to switch x and y and make the x negative. So J double prime would be switch x and y. This is x and this is y. And take the opposite of x. So it'll be 1 and 2 for J prime. K double, well that's J double prime. K double prime would be -5, +3. This should be -1. You don't bother the y. You leave the y alone and you take the opposite of the x. So leave the y alone, take the opposite of the x, and then L double prime would be switch these two and then take the opposite of x. So -4, +5. So that's 270 degrees worth of rotation, and we are going counterclockwise with this one. So that's going to the left. So here, let me go graph this. J double prime. So 1, 2, 3, 1, 2, 3, 4, 5, and then 1, 2, 3. And then L double prime is 1, 2, 3, 4. 1, 2, 3, 4, and 5. And if you wanted this to fit on the grid, you can always change the scaling. I just didn't want to. And that's our sequence of transformations. Okay? Alright, last two exercises. It says in exercise 10 and 11, determine whether the figure has rotational symmetry. If so, describe any rotations that map the figure onto itself. Okay, so if you notice here, all of these side limbs are the same and all of the angles are the same. So we would call this a 1, 2, 3, 4, 5. This is what we call a regular pentagon. Alright, so since this is a regular pentagon, in order to find out if this can be mapped onto each other, where it can be mapped onto itself, we just have to find out what the degrees of mapping it onto the self. So if I was to hold this in the center, and since it's a regular polygon, I would take 360 and divide it by 5. And let's see what that is. $360 divided by 5. Just a second. Let's cancel that. Alright, so let's check this out. So we would go, oopsie. $360 divided by 5, and that means I can rotate this 72 degrees and it would end up on top of itself. So if I was to put a pin right here and turn this either to the left or the right 72 degrees, this will end up right back on top of itself. Let me do another one. I'm going to add another 72 to this. So if I rotate it 144 degrees, it will end up back on top of itself. And I'm going to add another 72 to this. If I rotate it 216 degrees, it will end up back on top of itself. Okay. Alright, I'm going to add another 72 to this. And that's 288 degrees. It'll end up right back on top of itself. So that means if I turn it 1, 2, 3, 4 times, and these are all the degrees that I need to turn it by. And if I put my point in the center, and let me see if I add another 272, that puts me back at the original. So I can rotate this 4 times, once at 72 degrees, another one at 144 degrees, and another one at 216 degrees, and another one at 280 degrees. And so as long as the figure is a regular polygon, all you have to do is take the number of sides and divide it by 360, and that'll tell you how many times you can rotate it. And you can get the number of degrees by adding the original degree to each one. Or you can just multiply each one by the second one, 72 by 2, 72 by 3, 72 by 4. And if this was a square, then you take 360 and divide it into 4. And then you would get 45. No, I'm sorry. You would get 90. And then you get 180, then you get 270, and you're back at 360. So you can turn a square 3 times and map it on top of itself. Whereas you can turn a regular pentagon 4 times and map it onto itself. A regular hexagon would be 5 times you could rotate it around and turn it back onto itself. Now let's go here. This is not a regular polygon, number 11. And you can tell because they don't have the marks on the side to show you that all of the lengths are the same. And if you look at the angles, it has different drawings in the angles to show you that they're different lengths. So here, this does not have rotational symmetry. It doesn't have line symmetry either. In order for a figure to have rotational symmetry, it has to either be a regular polygon, or it has to have some kind of you have to be able to rotate it 180 degrees. And here, and it ends up on top of itself. None of that works here for this figure. I will see you guys on tomorrow, and bye.